All right, fellas, this is a quick review on topics 1.1 to 1.3 of AP Precalculus. I have 16 pages here. The idea is to keep this video under 10 minutes. So if it goes beyond, I'm going to make a part 2 of this. So I'm seeing these questions for the first time, so I don't know how much time it's going to take. Let's find out. And if you need private tutoring, feel free to reach out. All right, here we're given that there's a graph here, and we have to use this graph of the function, and it consists of 3 line segments. Obviously, we can see that. So use the graph to answer the following. On what open intervals is the function increasing? So increasing means that with the increasing value, we always look from left to right, correct? From the increasing from left to right. So if we are going from left to right, if y values are increasing or going up, basically if the function is going up, then we consider that increasing, right? So these two portions are increasing and they are asking decreasing, so the remaining portion is decreasing over here. So I'm going to mark that it starts from -1, open interval, -1, and all the way to what? 2, I think. Union then starts from 5 and goes all the way to 8. So 5 to 8. And when it is decreasing, so it starts from 2 and I think 5, right? 2 to 5. Yeah, that's where it is decreasing. Likewise, we have another function between -6 and 6, and again we need to answer increasing and decreasing intervals. So increasing interval likewise will be from, I believe, this point all the way to up to all the way till this point, and the rest of the points or rest of the intervals are decreasing. So increasing will be from, this is what, -2, correct? So -2 and open interval from 2, I believe, 2, and decreasing from -6 all the way, -6 to -2. Once again, they are asking open interval, although they have not written open here, but I assume they are looking for open intervals here. -6 to -2, and then I think from 2 to 6, right? Union 2 to 6. So that's the answer for this one. Okay. This is again on 1.1. If you notice, they have also given the topics on which the questions are based. Here we need to answer concavity. So when is it concave up or concave down? So guys, if you remember, I've talked about this in my earlier videos as well. Concavity is all about smiling and frowning. So when is the function smiling in nature? That's the overall idea over here. So it feels, I think the function is frowning till, I think all the way till here, right? And then it is a smiling in nature for the remaining portion. So the highlighted portion is concave down. Open intervals will be, I believe, -6 to 1. And when it is concave up will be, I believe, from 1 to 6, right? That's where it is smiling in nature. Same type of question, concave up and concave down. It's pretty straightforward, I believe. This is smiling in nature, then frowning in nature, and then smiling in nature. So I have shaded the smiling pieces, just concave up. So concave up will be from -2 to, I believe, 3, union 6 to 8, that's concave up, and concave down will be 3 to 6, right? So this is the concave down portion. Okay, this is on 1.2 rate of change. So we are given a couple of points here, A, B, C, D, E, and we have to find that in which of the following interval is the ROC positive and decreasing. Okay, positive and decreasing. What is the meaning of ROC being positive? ROC positive means that the function is increasing, and ROC decreasing means the function is concave down. I hope you know these terms. I've talked about these. If you don't, watch the 1.2 videos. I've talked about these terms in detail. So we are looking for the interval where the function is increasing and frowning as well. So obviously it is increasing here and it is increasing here as well. So where do you think it is increasing and concave down? I think A to B makes absolute sense, right? A to B is definitely increasing and concave down, which is literally the first option. I don't really, another option where it could have happened was from this origin to D, but there is actually no such option from origin to D, right? So the biggest interval on which this happens, where ROC is positive means the function is increasing and ROC is decreasing means the function is concave down, is A to B. Okay, another question. Here they are asking ROC is negative and decreasing. So ROC is negative when the function is decreasing, and ROC is decreasing obviously when the function is concave down. So when is the function decreasing? Now that's the question. Let's find out. The function is decreasing over here and over here, but the function is not concave down always from B to C, but from D to E, yes, it is always concave down. So concave down and decreasing from D to E, yes, definitely that is an option. So I'm going to mark D over here. Right. For each of the following functions, find the AROC within the interval of -2 to 4. I'm only going to do 2 and 4. I'm pretty sure the procedure is same. So I'm sure you can handle the other two. The formula for AROC is f of B minus f of A over B minus A. Right, so here I'm going to say that it will be g of 4 minus g of minus 2 over 4 minus minus 2. Just be very careful about the double negatives. What is g of 4? If I put 4 here, 4 times 2 is 8, 8 plus 8 is 16, and square root of 16 is 4, so 4 over here. Minus, what is g of -2? So 2 times -2 is -4. -4 plus 8 is 4. Square root of 4 is 2. So 4 minus 2 over 4 plus 2. 4 plus 2 is 6. So 4 minus 2 is 2. 2 over 6. The answer is 1 over 3. That will be the AROC between -2 and 4. Likewise over here, -2 and 4 points are right here. So the AROC will be k of, because the function is k of 4 minus k of -2 over 4 minus -2. K of 4 is 13, k of -2 is 0, this is 6, so the answer is 13 over 6. This is going to be the AROC of this function. Okay, we have 2 more questions. I'll probably do both. What were the points here? Again, it's -2 to 4. Okay. So -2 point is, well, right here, and 4 is right here. Okay, so we basically have to subtract what y values, right? So at 4, the y value is 5. So 5 minus, at -2, it is 6. So 6 over 4 minus -2. So it will be -1 over 6. That is the slope. Slope, as in we are calling it AROC. And here -2 is here, 4 is right here. So y2 minus y1 will be 3 minus -3. Be careful with the double negatives, over 4 minus -2. So this will be 6 over 6, which is just 1. So that's going to be our AROC. I hope this is making sense. If you think you have missed some concepts or you need extra help, feel free to reach out for private tutoring. All right. Here the graph is given between -6 and 6. We need to answer that what is the interval of x where the function is increasing at a decreasing rate. So again, they are just trying to trip us up with the terminology. G is increasing makes sense because the function is just climbing, but decreasing rate means concave down. So basically we are looking for a function for the interval where the function is increasing but concave down. So it is increasing from here to here, but it is concave down only, I believe, from here to here. Right, so it looks like 1 to 4, and yes, fortunately we do have an option 1 to 4 where it is increasing as well as it is frowning or concave down in nature. We have another question for the same graph. Where is the function increasing at increasing rate? So increasing rate obviously means that it is now concave up. So increasing with concavity, with concave up thing, is this is decreasing portion. The increasing portion is this one, right? This one, and it is also smiling in nature. So clearly that's, I hope you're not confused. I can erase the other portion. Yeah, it is from, so it is increasing and smiling as well. So it's, I think, from -2 to 1. Do we have an option? Yeah, we do have an option, -2 to 1. So it has to be option C over here. All right, guys, I'm gonna end this video here. For it looks like we just completed 5 pages, so maybe I need to make 3 parts of this video. But yeah, stay tuned. I'll link, everything in the description so that you can track it easily. All right, good luck. Bye bye.